Hi everyone, my name is Noor and I'm here presenting our paper Towards a Design Framework for Data-Driven Game Streaming, a Multi-Stakeholder Approach. And I'm presenting this on behalf of my PhD advisors, Erik Harpstead and Jessica Hammer. So much of the game streaming research efforts in recent years have focused on augmenting the streaming interface to address the participatory limitations in the video plus text chat paradigm. For example, on the left we have Lessel and others' Helpstone system from the game Hearthstone, which offers additional communication and interaction avenues for viewers via an overlay rendered onto the video stream of the game. And on the right, we have an audience participation game, or APG, called God of Socks and Spoons. APGs, such as the one developed by Glickman and others, offer viewers the ability to affect the game being played by the streamer via voting or aggregation mechanisms. And these efforts extend past the HCI research community. Twitch themselves released their Twitch extension toolkit, which allow developers to build interactive web overlays natively in the Twitch viewing interface. Here's an example of a Twitch extension that renders viewer interaction through a heat map. Now, while there have been many different prototypes and designs of live streaming interfaces, we argue that such systems are representative of a data-driven ecosystem. By data-driven, we are referring to streaming systems that rely on the collection, propagation, and rendering of live data. These systems use live data to power novel live streaming features, which can be collected from multiple sources, namely the game being streamed, such as the case of Helpstone, or as is common viewer voting data, as is the case in both Helpstone and God of Socks and Spoons. Additionally, data pipelines are reliant on different streaming stakeholders to produce, edit, and consume data, which is why we consider streaming an ecosystem of distributed stakeholders with varying goals, needs, and capacities to influence the data pipeline. Stakeholders in this ecosystem include game developers, streamers, moderators, viewers, researchers, and front-end designers. The buy-in of these stakeholders is needed to make systems that work in practice. For example, game developers need to implement data-driven features in their games. Streamers need to enable the data-driven functionalities onto their channel and leverage them to build relationships with their audience. Interface developers need to render the incoming data for viewers, and viewers need to engage with those new functionalities using those interfaces. In summary, the hunger for novel live streaming interactions continues to drive system development, and will likely continue to do so given the sustained growth of game streaming. However, we do not yet have a framework to talk about the relationship between different systems, nor do we have a design language to explore what kind of experiences they make possible. To continue the exploration of the data-driven game streaming experience established by previous systems and to legitimize the data-driven game streaming paradigm, it is important to formalize the shared design space that characterizes all data-driven game streaming experiences. However, given that this is an ecosystem of distributed stakeholders, and because these stakeholders are tightly coupled, we argue that we must work with all stakeholders together to understand what challenges they face, how their needs may be met, and what design opportunities exist. However, there has been no attempt to work with all stakeholders together for the purposes of design. We thus work with streaming stakeholders to understand how we can collectively move towards a shared definition of data-driven game streaming systems. Towards this goal, this paper shares the results of a two-phase design study conducted with target stakeholders in the distributed data-driven game streaming ecosystem. Stakeholders included game developers, streamers, viewers, moderators, designers, and researchers. In phase one, participants took part in affinity diagramming sessions to explore the breadth of features they want to use in future iterations of data-driven game streaming systems. In phase two, we explored the design space more deeply with participants via a design workshop, where participants worked in small groups to create low-fidelity prototypes of data-driven game streaming systems. Now, of course, I don't have the time to go through all of the results. However, I wanted to highlight a specific subset of our findings, which will help clarify the framework. One of these, that subset of findings from our study was a set of 7 design considerations. And design considerations describe guidelines that all data-driven game streaming systems should strive to include. And these are categories that largely focus on mitigating challenges or ethical concerns that participants had about data-driven game streaming. And we frame them as questions. Here are 3 examples. Design consideration number 2, how can the system incorporate features to help moderators do their job? Design consideration number 3, how does the system mitigate trolling or cheating behavior? And number 5, how does the system streamline the development process to minimize the added workload on developers? Now, our analysis of the phase 1 and 2 data, including those design considerations, as well as findings from previous work, led to a formulation of an early-stage design framework for data-driven game streaming. So the framework is illustrated here, and it shows the relationship between the core components of our framework. Each of the outer components, shown in green, represent a necessary facet of the design. The DC followed by numbers at each of these components refers to the design considerations that we previously discussed, and their respective location in this framework describes the stage of the design process that the design consideration comes into play. Central to the framework and linking these outer components together, we place abstract actions, which serve as an alignment mechanism between these different perspectives in the design process. The core of abstract actions is all about asking the questions, what will the user do? What actions are they expected to take? And these abstract actions are interface agnostic, meaning they are not concerned with visual appearance, UI specifics, or implementation. The focus of this component is entirely on identifying what actions need to be performed, rather than dwell on how these actions are to be taken. Next, we have the experience component. And the primary focus of the experience component is on establishing a clear design goal and target user. Before, we had abstract actions where design teams were asked to identify what actions the user can take. Here, at the user interaction component, it's all about how the user completes those actions. So structuring our framework this way allows design teams navigate the specific challenges that come with prototyping interfaces for streaming. Finally, we have the data behavior component, which is concerned with one of the most critical pillars of data-driven game streaming, which is the data itself. And at this stage, we borrow from file system terminology to define the data privileges of each stakeholder. And in considering these data operations, 4 of them emerge. There's reading data, writing data, deleting, and manipulating data. By providing such a framework for future research, our work contributes to the advancing of the field of HCI and facilitating the development of more inclusive, engaging, and ethically sound data-driven game streaming experiences. And in doing so, we push the streaming experience to move past the video and text origins and into a new generation of live interaction and shared engagement. Thank you so much for listening. Please feel free to read the paper to get more information about our framework.